All right, everyone. I'm Sean Moran with Darkhive. I'm the technical lead for Red Queen. Darkhive is primarily a drone company, but we have a whole ecosystem enabling autonomy for all, democratizing that ability throughout the battle space all the way to the edge. We first started this project with the 3rd ASOS up in Alaska. If you've ever tried to tap on a phone screen with gloves on, you can understand why having the voice capability for commands is really important. The big things with Red Queen that I saw right off the bat with coming onto the company, I had first gotten ATAK in 2013. And it was a game changer on, we were using VisiVis on the up armored window. But we noticed immediately it was a great planning tool and it was a great after action tool. And it gave us Blue Force tracking in a better form factor. But what we really missed was the real-time update and query of the map. Just because when you're in a situation where high tempo, hostiles in the area, you're not actually able to drop points, you're not able to ask range and bearing, etc. All right, we're gonna do a quick demo on this, and you guys can see this in the demo room today at 3 and tomorrow at 10. So this is live on TAC.gov. It will be on the Play Store in the next week or two, so if you want to check it out, feel free to. I will point you to the tutorials real quick. It has all the commands that we currently offer. If you want to start training your guys or you want to get up on this, just go through this and start giving commands. It is a command-based system. There is a slight amount of training. Usually folks within the first 10 to 15 minutes, they have their commands that they want to use a lot, and they can use it effectively. So I think the most important one on my side, especially when you're in a decision-making position, is having your guys passing out real-time information. So the first command I'll show you is being able to drop a point. Hostile marker at 500 meters, bearing 271, label hostile Charlie, with remarks, 2 military-age individuals carrying AK-47s.
Placed hostile marker at 500 meters with bearing 271 degrees, labeled hostile Charlie, with remarks, 2 military-age individuals carrying AK-47.
So we've enabled the ability to go everything from elevation, remarks, but you can also just do something very quick like place point here.
Placed point at self-location.
So we're trying to be able to affect on, depending on your situation, what do you need to mark, how much information can you provide, and make sure that decision makers have that information to get you help when you need it. Another really useful tool is Bloodhound. I know a lot of folks use it. So we've enabled the dynamic update side of that. So say you're in a scenario where you have a helicopter coming in, maybe you're doing CAS, maybe you're doing a CAS evac, and you need to know when they're a certain distance out. So you can either clear a landing zone or get your folks out of there if you're doing a 5 or a 9 line. Bloodhound 2, Duster Charlie, update every 100 meters. Oh, maybe that's the wrong name. Let's zoom back out. Oh, there we go. Bloodhound 2, Duster Alpha, notify at 10 kilometers.
Bloodhound to Duster Alpha, notify at 10 kilometers.
So what this enables someone to do is, they can continue managing their troops, ensuring they're in the right placement, and they'll get notified once that bird is actually close enough that they need to start taking action.
Bloodhound notification. Duster Alpha is 6,459 meters away at 284 magnetic.
Cancel all bloodhounds.
All bloodhounds removed.
Similar thing with geofences. You're able to set up geofences, let them sit there. You'll get notified when it happens. We're currently enabled with Invisio and Peltor as well. So if you don't want this output coming out while you're in a dynamic environment, we can support that. We support wake word mode, which is great, especially if you're in a medical situation. You need to quickly and easily be able to say things, and you're using both hands. But equally, I think one of the most useful things is the push to talk on the top. Just volume up button, hold it down. and you're good to go. So I think like if you guys are checking this out on TAC.gov, definitely defer to that. And then if you have Peltors and Visios, check that out as well. All right. So here's a list of some of the commands that we provide. And really what we're trying to hit on is the core ATAK features. Currently we have some UAS integration, takeoff, land, return to home. And we're heavily trying to build that out. Obviously, one person, one drone is not going to win the next fight. So an important thing on our end is having the ability to allow people to control multiple drones at once and be able to set something out on a mission and continue on what they were already doing. So we have an open architecture. This is completely GOTS. You can have access to it through get.tac.gov or the app gate now. So we're working on third-party integrations. We're currently integrated with UAS tool and the Oscar plugin through Air Dominance. So if you're interested, you have a pipeline or you have a plugin that you are currently using that you'd like to be integrated with, definitely have a conversation with us. We're going to continue adding features to this. But how we want to keep this product going after this SBIR is having the community come out and give us custom things they want to put in there, and then we'll give it to the entire community. So what's next for Red Queen? Our SBIR is over. We still think this is a very, very useful tool. We're going to continue iterating on that, and we really appreciate any feedback on things that you guys really want to see done. One of the big things is context awareness. We're integrating in the Android compass. We want to integrate other devices in there. The important part being, hey, I don't know what bearing 271 is. Just to enable the ability for someone in a high tempo situation to be able to rattle off some position, get some situational awareness on that. We're currently heavily working with on-device LLMs. It's always a work in progress, working with OpenCL, and anyone who's worked with Qualcomm understands that. But we've had a lot of success so far. We want to be able to have this not be purely command-based and enable people to say whatever they want to, or be able to leverage your radio transmissions that you're already saying. And like I mentioned before, the UAS tool integration I think is really important. We're going to keep pushing on that. And as well, obviously, ATAK is a community of plugins, largely, so being able to integrate with stuff that you guys are using on a day-to-day. All right, so how do you get involved? How do you work with us? How do you make Red Queen more useful for the users? First and foremost, again, we're attacking those core functionalities, the things that touch a lot of mission sets. But if you have a good use case that you feel like this would really help you out in, let us know. It might be something that we're already working on. We can give you guys a roadmap, or it's something that maybe we can get a contract with and start pushing that forward for you. Same thing with the drones. Obviously, we have a lot of UXVs out there. If you have to have one person controlling each one of those, it's not going to scale very well. So if you have a UXV platform or you're working with one or you're looking to buy one, please talk to us and let us know if we can help with the voice command side. We are currently integrated into ATAK, but this is set up as a companion application, so it's not just for ATAK. Anything Android, we also have a Dockerized version of this. So obviously, if you have something that voice commands could be really useful for, please let us know. And if you have any feedback, obviously this is live on TAC.gov. Try it out if you have any feedback. If there's things that aren't natural for you to say, please hit us up on our support@darkhive.com. And here's the link right here for TAC.gov. All right, any questions? Okay, yep.
Would you rather use those over the?
Yeah, it's just the single, if all you
Okay,
are is
yeah, okay, we'll do that.
Yeah, right there.
Let's try this. Cross your fingers. It's working. All right, great. There's a lot of technology that came together very quickly right before the talk. So I'm going to go through things really, really quickly. I've only got 15 minutes, but I want to save time for actually showing you things at the end. So to contrast what you just saw, what DarkHive does is awesome. And if you know the technology behind the scenes, you know how difficult that was and everything. What they're doing is specific and mission focused, I would say. What we were trying to do, because we play well with others, we play well with them, is not to step on their toes, but to do something different. And what we're trying to do is generalized voice command control of ATAK and a few other really neat features that I think you'll find pretty interesting. So I'm going to go through these quickly, but basically one of the Achilles heels traditionally about ATAK is requires their hands and eyes to operate. And we have friends up at Jaber also in Arctic gear. You can't deglove, you can't take your goggles off to really do what you need to do. Or what I've learned with also going out with infantry groups and stuff using ATAK is sometimes their eyes and hands are otherwise engaged. Also, Air Force aircraft maintenance workers that would like to use ATAK. Similarly, their hands are on the F-22 landing gear, and they would still like to use ATAK mainly for collaboration and communication, but in some cases our eyes and hands are otherwise engaged. So the idea was, can we do command and control by voice of the core functionality, but also make it so that it works with no changes to the underlying plugins or any of the other core of ATAK. Usable in high noise environments, and I'm not going to read the slides, you can see it. But basically make it so that you have full voice enablement where you could leave it perhaps closed up on your chest and still do what you need to do, not have to deglove, not need to use your hands, etc. So pretty high bar. In the future, being able, where I want to go with it is to have it be more like, I'm sorry to say the words, but Siri or Alexa. Okay, not in the room. So be able to use it like Siri or Alexa, where it can prompt you. It's your buddy in your pocket that walks you through things too. So that's ultimately where I think we'd like to go to. Components of what we're doing on our project is straight up voice command and control of ATAK. A couple of other neat things that AFRL had on our project was also voice-based authentication and differentiating speakers that it will know it's me and be able to then log me in. Detecting emotion and distress and duress in the speaker's voice. Background noise characterization, such as knowing whether you're running through the forest, whether you're in a gunfight, whether you are on a rotorcraft, etc. And then the most interesting one that I want to really jump to quickly is voice-to-voice. It's supposed to be limited real-time translation, but that's what I want to be sure to show you. Let's go forward. So voice-based command and control of ATAK, right now it's operating. You're about to see that in the video at the end. Requires no modification to the underlying code. We're actually using a trick to scrape the screen for UI elements that exist on the screen, and you speaking those UI elements is the same as you tapping it. That's the trick. So it uses that, it works for core ATAK functionality, and it works with existing and new ATAK plugins. If you've coded your ATAK plugin the way you should, using normal processes, you don't have to do anything for it to be voice-enabled using the VoiceTAK plugin. Simple API behind the scenes also. If you want to take control, it's a simple text file where you can define this command, fire this. If they say this, fire that. So it's very completely open and completely able to be expanded by you. As far as voice-based authentication, long story short, we got that to work where it, within 10 seconds, can identify you versus somebody else. We were looking at that originally as a way to log you into ATAK and to confirm that when you're saying something, you are who you say you are. That's working, but we haven't fully integrated that into ATAK yet. So voice authentication, speaker differentiation, also being able to differentiate one speaker versus another speaker was something else that we developed into the plugin also. And you can see there are videos attached to each one of these. Speaker emotion and sentiment detection, the idea was when our guy is talking, can we tell whether he's under duress or not, or whether he's being coerced? I didn't think we would be able to do this, but we did. We trained neural networks on a bunch of old movie clips that had anger, fear, other emotions attached to it, and trained the neural network on it, and then played back actors or us trying to act in a certain way, and no kidding, it was able to detect those reasonably. This was also more academic, researchy sort of thing. We haven't identified it, we haven't integrated it fully into ATAK yet, but in the future, part of our idea was to have a little emoticon when somebody is speaking in ATAK chat that identifies the perceived emotion behind the speech. Background noise characterization, that also worked pretty well. Gunfire, helicopter, other sorts of environments, we were also able to differentiate. And being able to have some sort of emoticon that would be playing that for a particular speaker while they're talking was also something that we plan to add. Here's what I want to end on, though, and I have a video that we're going to play in just a moment. Voice-to-voice real-time translation. So in World War II, as Dr. Crow mentioned, they had the pointy-talkie, which were, if you were shot down over enemy lines and you didn't speak French, you would point to this side and it would have the French translation. So the idea was, could we do a voicey-talkie where basically I would be able to say something in English and then it would speak it in, let's say, Ukrainian or something. So we did that, and we were able to make that work, but then we had an interesting, better idea. What if I could do dynamic real-time translation on ATAK, where I could be speaking into my ATAK, perhaps with it closed up on my chest, and it's converting what I'm saying to text, and then that could go out to all of you that speak English. But if this gentleman speaks Ukrainian, he would get it in English text. On his phone, it would translate it to Ukrainian, and he would hear it in his ear and or see it on his screen in Ukrainian. He speaks Ukrainian back, translates it on his side to English to send it back. Honestly, I didn't think we were going to pull this off. It's a lot of difficulty to do that. It took a lot of time and a lot of trouble. As a former speaker was mentioning, doing LLMs on these platforms is tough, and it took a lot of time to get as much as we could out of the hardware. But we did it, and it actually works, and Ukrainian is supported now, and we've got a bunch of other languages that we can also support. Let's play the video now, and then if we can go to 1.5 speed to save some time.
Hey, ATAK.
A little quieter.
Список контактів.
So this was an
Hey,
earlier,
ATAK.
earlier prototype from about 3 months ago. So on the side, he's using Google text-to-speech to speak Ukrainian. We didn't have a native speaker handy at the time.
Hey, ATAK. Send. Charlie team, check in.
You see it send to that side.
Hey, ATAK.
Well, in a moment, it'll say.
Надіслати. Команда Чарлі доступна.
Incoming message. Charlie's team accessible.
So it was real-time translated on there. You saw a little bit of a lag, but not too bad. And to be,
Надіслати. Ворог помічений за 2 кілометри на південь від вас.
anybody speak Ukrainian in here? Okay, Russian, Tyler? Okay.
Incoming message. The enemies to TWO kilometers south of you.
Let me foot stomp something. That's all just on the phone.
Hey,
no
yeah.
cloud, no special hardware, no anything.
Send. Deployment size.
Вхідне повідомлення.
Hey, ATAK.
Надіслати 40 військ.
So she's speaking in Ukrainian, and then you'll see it pop up on the other side.
Incoming message. 40 troops.
So you're seeing chat functionality, but
Yeah,
also
yeah.
you can talk to it and control it by
Send.
voice in
Engaging
Ukrainian
targets.
also.
Back. Back.
Such as straight up English command and control of ATAK and all major
Вхідне
functions.
повідомлення Енга Інстарджетс.
Now she is controlling her ATAK as well. So we also did the FireTools plugin, which most of you know.
Hey, ATAK.
No changes whatsoever to the tool.
Target.
No
1
reprogramming.
kilometer south. Hey, ATAK. Focus. Target 6.
So issuing voice commands in English.
Hey, ATAK. Contact list. Chat. Hey, ATAK. Send enemy engaged.
Вхідне повідомлення ENE Engaged.
Hey, ATAK.
Надіслати кількість втрат.
Incoming message, the number of losses.
Hey, ATAK. Send 10 casualties.
Вхідне повідомлення TN Casualties.
Hey, ATAK.
I think we're almost at the
Send enemy spotted 4 miles east. Hey, ATAK.
Надіслати розмір розгортання.
Incoming message, the size of the deployment.
Hey, ATAK. Send 10 troops.
Okay, I think that's about the video, right?
Hey,
We can
ATAK.
probably cut it off.
Надіслати залучення ворога.
Incoming message, enemies to engagement.
You want to stop the video and cut back over to the laptop? And we'll wrap. Thanks. So again, what you saw right there was voice command and control of ATAK in English and being able to go through all major functions of ATAK there. We also do audio chat where you can send an audio message to the other side as well as it converting audio directly to text and being able to send it, which is obviously much less bandwidth. On the other side, the person gets to define whether they hear it spoken or just in text, and whatever their language is that they've configured is how they hear it. They speak back in their language, and then it converts back and sends back over. So that's what you just saw in all of that. And again, no cloud dependencies, no special hardware, anything like that. And it works. And it's also all been uploaded to the TAC.gov site in Git. It's there. I've got the APKs. I'll be demonstrating it over in the exhibit area here in just a little bit as well. I've got a bunch of devices and we can try it out, and I'm dying to find a Russian or Ukrainian speaker. So here's where we're at with it. It works. It's time to take it into the field. We've tested it in high noise environments. Part of why we do the background noise characterization is it lets us then improve the sensitivity of the model. If it knows what the background noise is, then it makes it even more sensitive and stuff. So we're ready right now to get this out there and get feedback from people, iterate, refine it, but everything will be released for free on TAC.gov. So if you're an end user group that would like to test this, love to talk to you. And then of course, final reporting and release of this in the TAC.gov's app store. And release of the source code as well. So happy to work with anybody and answer any questions maybe at the end. So thank you for your time.
And you'd love to have phase 3 funding, that's what
You know, thank you. I actually would. That would be really great because we did Ukrainian. We can do lots of other languages too. And one gentleman in here earlier was asking about Japanese. Yeah, we have basically 12 languages would be easy for us to do out of 64 total we could do. But 12 of them, the major ones you would care about, we can do relatively straightforward.
We're in questions at the end. Sorry.
Hold that thought. Thank you very much for your time. Thanks.
All right, we're gonna have the Certus team come up here and brief their voice work. They have less slides than the other group, but they have a whole CIBR effort that they're also working on that's being briefed this afternoon, the AFRL ML CIBR. I actually don't know the name of it, but ML something. Team ML, yeah. Okay. All you, and then you can just change this.
All right, hello everyone. Brian Quinn, not Rick Newkirk. He couldn't be here. So I'm here on behalf of Certus Innovations. We're talking about some work that we did under our CIBR Team ML called TAC Talk, which is a collaboration between Certus Innovations and RTX BBN Technologies. So TAC Talk specifically is about low bandwidth comms regardless of what the situation is. So we use a mixture of machine learning models for speech to text, text to text translation, and then text to speech with the option to apply a custom voice clone profile to allow near real-time voice-to-voice communication over constrained communication systems. So we worked with mesh networks before, like LoRa, Meshtastic, that sort of thing. You can also hypothetically do it over LPI, LPD waveforms. The math checks out, though we haven't actually had a chance to test that yet. And you can do it across different languages without requiring a server. So and you can see it's almost available in the Play Store. We have 2 asterisks because there is a little bit of a paperwork holdup, but we are on the way to having this ready for public release. So you can see here the concept of operations. You will speak on your own phone in your native language using the push-to-talk functionality. In the future, it might be integrated with like push-to-talk headset or something like that to provide better hands-free operation. And one of our automatic speech recognition or text-to-speech models will take that audio and transcribe it for you. We've tested 2 different models for this. Whisper, which is open source and supports many languages, though there are some problems with background noise depending on the language, and lower resource languages don't work quite as well. And we've also tested BBN's Cyrus model, which is specifically designed for military audio. So it's trained to be resistant to military background noises, and it can be trained on specific controlled vocabularies, like the kind of jargon that you might use in a particular career field, or if you're maintaining good radio discipline. So once we have that text, the text is what's actually transmitted. By default, it uses the built-in TAC messaging service, so there are other options available for that. And by transmitting the text, that's where we get tremendous savings in bandwidth of up to 99%, depending on the codec that you're using. There are some fancier real-time compression codecs that can provide very good compression on that real-time audio, but if you're using something a little more basic, like ALAW or MULAW compression, you're looking at about a 99% reduction in bandwidth. And that's what allows us to work over those resource-constrained systems like the mesh networks and the LPI, LPD waveforms. So once that text arrives at its recipient, you can do either a broadcast or you can do a point-to-point communication. It'll arrive in your language, and then depending on the settings of the recipient's device, it'll translate it directly into their language. So currently we use No Language Left Behind from Metasystems, which is an open model that does 200 different languages of direct translation. We've tested this with a few different languages. So we've used Ukrainian with text-to-speech and Google Translate. We've done a little bit of French and Spanish. I took French in high school. Hypothetically, I would remember it in my 30s. But a couple of people who have some very rudimentary Spanish, so we've tested that as well. And then we tested it live with some Lithuanian JTACs at Northern Strike a couple weeks ago. They said that the error rate for the Lithuanian speech-to-text and translation was one of the better ones that they'd seen, but all the other ones that they've seen were terrible, so take that for what you will. And we got an impromptu live test with Dutch earlier today. We ran into some Dutch folks at the conference that one of my coworkers had run into at one of the social events earlier this week, and so we did a live demo where they would speak Dutch into one phone and it would automatically translate it into English on our phone, and we went back and forth like that. And then finally, once we have the text in the recipient's language, we can use text-to-speech. Currently, we're using the stock Google TTS, but that only supports about 53 languages, so which is good enough to get started with, but in the future, we might want to switch to something like IMS Toucan, which is an open model that claims they support 4,000 languages. Now, if you dig into that number, you'll see that only about 260 of them actually have any kind of supervised training, and the rest of them are zero-shot languages. So, I would take that number with a grain of salt. So we do that speech synthesis, and then we have the option at the end to apply a voice clone profile from the original speaker. So currently we're using a post hoc system instead of an end-to-end speech synthesis with voice cloning. The benefit to this is that it is very easy to implement and it works very quickly. The drawback is that it only picks up on your particular inflection in your speech, like when for me, it sounds very nasally, which on the one hand is offensive, on the other hand it's accurate. But it does miss out on some of the nuance of how that particular person speaks. If you have a particular rate or cadence of speech that is different from how the speech synthesis engine works, that won't be replicated. So in all, there's a little bit of latency with doing this because we have to run these models on the phone in real time. The latency is on the order of 1 second. We haven't really looked at what if that is an amortized cost versus what scales with the length of the message. In general, the messages that we've sent back and forth are more on the order of, hi, how are you doing? When we were talking to the Dutch guys earlier, they used it to say, my partner is shy, so he doesn't want to talk into the machine. And they came through with that pretty well. There's still a little bit of work to be done, especially on the translation piece, looking at the specific vocabularies that go along with these military use cases. So one thing that they did, they wanted to test out is, if we use the Dutch terms for being under fire, does it accurately represent that, not only on the speech to text, but also does that make it through translation and come out as saying, I am under fire in English on the text to speech side? And the answer was, it came pretty close. It said firefighting instead of under fire, which is definitely something that as this CIBR progresses, we want to look for data sets that we can use to fine-tune these models to these specific use cases. We're also looking for other use cases where this technology can be applied. So we've gotten some pushback from like JTACs that we've shown this to for the translation piece, because they say, well, we all have to speak English, all the pilots speak English, everyone is out there speaking English. And then you talk to some other people who say, have you ever heard a French JTAC speaking English across a degraded comms channel? Like, personally, no, I haven't. But I can picture the situation that you're describing there. So some of the benefits that this gives outside of just the compression and the translation is that you have a text record of what was said. And assuming that that's accurate, and obviously that needs a little asterisk next to it, especially during the development phase, you can then, if you miss a message, instead of having to say again, or just completely missing that message if you're really locked in on something, you can then just look back through the chat history and see what was said, when was it said, are there any messages that I haven't responded to yet? And there are ways that this can be extended for speaker identification, mission transcript generation, speaker diarization, that sort of thing. Currently, it's all set up to run on the phones. You can use it through a TAC-server, but you don't have to. There's no processing done on the TAC-server. But once the technology is proved out, those use cases can be extended to situations where you would want to run some of these on the TAC-server. Maybe you don't want to use TAC Talk end to end, but you want those capabilities of capturing what was said, by whom, when was it said, what language was it in, can we generate a transcript that is in the language of the person who's reading it. So right now, as Sunshine mentioned earlier, we're about halfway through our CIBR, though I have been advised to say that we don't claim CIBR data rights to any of this technology. So it's going to be available on tac.gov. It's going to be available in the Play Store, and it is government unlimited rights. And as Ralph would say, we're always looking for transition funding. So if anyone is interested in this technology, please feel free to reach out to me afterwards, or if you know Nate Soul from BBN, as everyone does, he is the BBN tech lead on this. So we are always looking for new use cases and new ways that this technology can be applied. Right, I think that is that's all I have for now. Thank you.
Okay, as promised, we'll do questions now. There's the microphone there, so if there's any questions, please ask them now.
So you guys are on phase 2 servers?
Yes.
Yes.
A lot of the Red Queen piece over there that Sean was demonstrating has been pulled into a phase 3 IEP with the Air Force.
Yeah, question on translation. So have you tested for the accuracy of the translation? If so, what kind of metrics did you use and what were the results?
I'll take a piece of that. So far, I mean, to be honest, a lot of subjective testing and stuff with native speakers. There is We have a little bit more time left in our SBIR, so there is a bunch of metrics. I'm sorry, I'm blanking on the name of it right now for actually doing that. It's an automated system. I'm really sorry I'm blanking on the name of it right now, but there is basically a way of stock phrases and then translations and translate back and then coming up with that accuracy. If you meet me over in the exhibit area, I'll look up the name of it and stuff, but we're trying to quantify it as the end.
Yeah, the gold standards are blue or word error count.
Yep,
The red.
yep,
So,
I think that was it. Yep.
Okay.
Thank you, ma'am.
And honestly, my answer is pretty similar. When we have used it with native speakers of those languages for short messages, they've said that in general, it feels pretty good, which is not, super scientific. Because we are mostly based off of open source models, we do have the blue scores and the CHRF++ scores from that Meta has released for the NLLB model, though in general we haven't conducted our own tests to independently verify those.
Okay, one last question is, are these short utterance that you guys are working on, or is it could be a stream of speech? What are we talking about?
So for our current use case, it's mostly short messages. I see ways that it could be adapted for streaming, but for our current use case of push to talk with translation involved, it would be for us mostly short messages, maybe a paragraph at most.
For us, typically what you get is if you have a limited corpus, a limited set of words that are active at one time and context dependent, your recognition rates are up in the 98%, something like that, even high noise environments. So if you can restrict it, kind of like what Darkhai was saying too, there are only like 8 words active, 8 commands right now, and if I pick this one, then there are another number of 8 or whatever. That's how you get really, really high accuracy for commands. Separate from that is what you're asking is narrative speech, which is me just talking and it being able to do it. Traditional, back to Dragon Naturally Speaking days and other stuff, they were around 80%. Now with these LLM models, we're actually up in the 90s%, but also it is somewhat context dependent. And obviously it takes a little bit longer to be able to handle that. But we're above 90%, we believe, with respect to narrative speech.
Thank you.
We can go, yeah.
Any other questions?
So for Darkhive, how do we do integrations, for instance, for plugins? You sort of alluded to that, but it wasn't quite clear.
Yeah, so from our end, we currently have a command line tool. So we're using finite state transducers. It is built before runtime. So we built a command line utility for folks to be able to use that. The biggest thing we want to ensure is that we don't end up crushing that vector space. And I can't use point dropper because somebody used a similar phrase, right? So we've really pushed harder on making it deterministic. What we have done in the past is you can add, call signs so that, hey, I want this behavior, route me this when they ask to drop this point. And same thing with the Oscar plugin with AADOM. Passing along those commands to them, they can define their own finite state transducer and act with it accordingly.
Similar question for Kevin at IoTAI. Are your shortcuts that you showed there parameterizable? In other words, you look like you did an alias, but sometimes there's a parameter that gets pulled out somewhere else.
Yeah,
Does that
correct.
language support that?
Yep, yeah, it does. So it's all context dependent, so you define what context you're in so that I can say, for example, all chat, and then it could prompt me who, and then I have a number of call signs that I could pick. So it is all context dependent. And again, that's how you get really, really good recognition in high noise environments.
Okay, and then for Certus, this is almost a softball. Tell me, you're targeting low bandwidth communications. Have you done what's your plans, or maybe you already have low bandwidth radios that you're working or doing?
Yeah, so the bandwidth requirements that we're looking at are on the order of a few kilobytes to maybe a couple tens of kilobytes per second, which puts us squarely in the range of any kind of LoRa or Sigfox or those low power local networks or LPWAN technologies. So we have tested it a little bit with LoRa-based mesh networks, because there are many that are already incorporated. They have good tooling support in the TAC ecosystem. We want to expand out to more of those over the course of this project. And if we could get to the point where we could test with some LPI, LPD waveforms like those low band with fast frequency hopping, or widespread spectrum waveforms, we think that there could be a lot of value in combining the voice compression with the tactical waveforms. Though we have no current path forward on that.
Especially for Darkive and IoTAI, you guys are going to publish the how-to for those pretty soon, I would hope.
Yeah. So definitely publishing those. We have our wiki; those were in our slides right there. If you have a TAC.gov account, you can check that out. You can go through our architecture and how you can integrate, and even from any application you want to use outside of ATAK, you can also use our commands. There was one question that came in. Are any of these projects addressing one-to-many challenges to control multiple UXSs? Yeah, that's one of the things we're really pushing hard on. I think our first step is, the first command that we want to work with is go check out marker X. At a certain altitude, get eyes on, let folks continue on with their mission. But equally, we're working towards a point where you can just say, I need to check out this marker, and we decide which drone has the capability and is closest and is not currently on a mission.
We did something kind of similar too. We, in order to make sure that our voice enablement worked with just pretty much any plugin, we used our plugin that's used for controlling a bunch of our other sensor devices. We make EW sensors and things like that, and being able to control multiple ones of them at the same time, and basically moved it over and didn't need to do anything special to voice enable it. So there's also a video of that we'll be posting.
Okay, thank you all for attending this session. They'll be in Salon 5 doing demos this afternoon and tomorrow. We'd love to collect feedback and get opinions to keep making it better. If you have any questions, please reach out to me, Sunshine Stacy. Their names are also on the slides, so once they're uploaded to TAC.gov, you'll be able to actually reach out to them directly. But yeah, other than that, we have our TAC CAD presentation in here next with Nate Soul, and that's a really good one. What? 2:15. And then an AFRL ML portfolio is after that. Thank you.
Thanks.